programming is a method for finding maximum or minimum values. I'm going to be honest, I don't think this will make sense to a lot of you today. I think I'm going to teach you something that will seem confusing today that will hopefully make sense Monday or Tuesday when we get to some applications. If I have time, I'll try and get it to make sense today. Okay? The maximum or minimum values you are going to be finding next week are going to be things like the cost of making something or the profit from selling something. Okay? And you're going to figure out exactly how people get the most money or the least money out of a process. Today we just have to talk about the math behind it, so I apologize if it'll seem confusing. There's a couple of terms you have to know. One is constraints. What does the word constraint mean in English?
Is that like a hold?
It's like a hold, you said? Yeah, that's a great word. A constraint is like a hold. It's something that holds you back. Anything else? You think of like a constraint.
Against?
Pardon?
Against.
Against? Well, yeah, con, the prefix does mean against most of the time. It's similar to restraint.
And then like, yeah, hold that.
So it's like a hold against.
It's like a restraining.
Like a restraining order, yeah. It's like a restraining order, but restrain means, usually means to do again, like repeat. Constraint means against. It's like a hold against something.
I think you spelled it wrong. No.
I think I left there's supposed to be an I and an N in there. I think I spelled it sloppy. I think I wrote it sloppy. Okay, a constraint for math purposes, a constraint will be represented by a linear inequality. Remember linear inequalities? Actually, they'll be represented by multiple linear inequalities. Sorry for those of you who are keeping up. The constraints will be represented by multiple linear inequalities.
You didn't write multiple.
I didn't write multiple, but I'm saying it. Represented by linear inequalities. Feel free to write it. Now, the last question on the test yesterday was you had to graph more than one linear inequality on the same graph, right? Well, that was your practice for this. That was your build-up for this. Really? There's a nice smooth segue into today's lecture. Constraints are represented by multiple linear inequalities. Yes? Okay. There's something called an objective function.
Of means against, which means the function that is against something.
Good job.
Shut up.
No, hey,
Sorry.
no patience today, none. Objective function, breaking down these words, I'm not actually sure why they use the word objective in here, to be honest. Function simply refers to, it's a function in the math sense. It passes the vertical line test. There is only one representation of the dependent variable for each iteration of the independent variable, which is a fancy way of saying there's one y for each x. Now, the objective part, I'm honestly not sure why it's there, but the objective function it's actually a set of parallel lines. The objective function is a set of parallel lines, and there's a way we represent that. And I'll get to that visually in a minute or two, I hope. You got your constraints, you've got your objective function, and you've got a rule. And the rule is, this rule probably will not make much sense yet, but the rule is the maximum or minimum value of the objective function occurs at a point where the constraints intersect. The maximum or minimum value of the objective function occurs at a point where the constraints intersect. I'm going to let that sentence sit there for a minute, get it written down, and then I'm going to try and start telling you what it means, and we'll go into some examples.
Question about it.
Yes, please.
Does that mean like, isn't like the two lines, like, they intersect, and then the ordered pair that they intersect in.
Yes, at the ordered pair where they intersect at.
So why do you have to use the word constraints? Why can't you just be like the ordered pair?
Well, constraints actually refers to these linear inequalities. So you're going to have to graph them like lines. Where they intersect, that's what the last test was about, finding where lines intersect.
Constraints are ordered pairs?
No, that was close. I mean, I may have misunderstood Amanda's question a little bit. Constraints are the lines, the linear inequalities. They're going to be lines that we graph. So it's going to be where lines intersect. Plus, these are linear inequalities. You're going to be shading one side or the other of the lines. Okay? The objective function is actually a set of lines. That's going to be the weirdest part. Constraints, linear inequalities, just like the last problem on the last test. First thing you're going to need to do is graph a bunch of linear inequalities and find where they all intersect. Okay? I'll move over here and put an example up. I have to pick my example carefully, so I want this to work and not have like all sorts of decimals and fractions that'll make it more confusing. Okay. So now, we'll go to an example here. Given the following constraints. Sarah, help me spell this right.
C-O-N.
All right.
S-T-R-A-I.
Given the following constraints. Does everyone agree with Sarah's spelling?
Yeah.
Sure, why not?
All right. No one's going to call her on it anyway. Given the following constraints, and these constraints are going to be a system of linear inequalities. They're going to be y is greater than 0, x is greater than 0. Let's see. X plus y equals, no, x plus y is less than or equal to 10. 2x. Hang on, give me a second on this one. Two x plus y is less than or equal to 13.
Do you make these up or do you make them up?
I'm making this one up, which is always dangerous. So give me a second to make sure they're going to work the way I want it to. Yes, that one will work the way I want it to. If this blows up, I will definitely grab the next one from the book. Given the following strengths,